we talk about why these issues are arises in our world, so one thing comes in the mind is that all these issues are arises because of all these issues are arises because of there is a imbalancement in the chemistry of environment, in the chemistry of water bodies, in the chemistry of air qualities, and that's why we have to think on it, and we have to balance the chemistry of the environment, chemistry of the water bodies, chemistry of the air quality, etc. Guys, remember that when we address these problems of the chemistries, then and then only we can be able to achieve the sustainable future. Sustainable future is nothing but the ability of humankind to fulfill the needs of today's requirements without compromising the future of new generation. So that's why let us join with us to make a better planet. Remember that this world should be a better place because we are born in it. Thank you.
Thank you, sir. Now, with due respect, I would like to call upon Dr. Ansari Muhammad Harun Muhammad Ramzan, sir, for presidential address.
Good afternoon to all of you. It is a great privilege for J.A.T. Arts Science Commerce College, Women Malegaon, District Nasik, Maharashtra, India, to have organized such phenomenal webinar at international level under the title Chemistry of Sustainable Future. As the head of the institution, I, on behalf of J.A.T. Management, J.A.T. Arts Science Commerce College, staff members and students, welcome all the prestigious resources person, various participants and students. Finally, I appreciated the efforts of Department of Chemistry for organizing such webinar, and it will be successfully, and with the help of it, tried to take the college to the new level. And at last, I wish everyone to well informed and enlightened by this session of this program, and hence I conclude my speech. Thank you to all.
Thank you, sir. Now, I would like to call upon Dr. Arif Momi Aziz, sir, for introduction and welcome of our first resource person.
Thank you, madam. So, dear participants, it is a matter of great pride and pleasure that we have two of the very prestigious personalities with us to join in this webinar, and first of which is from Department of Chemistry, Savitribai Phule Pune University, with whom I mean Dr. N.R. Dhatrak sir. So let me introduce him. Dr. N.R. Dhatrak sir is an associate professor in the Department of Chemistry, Savitribai Phule Pune University, and he has a teaching experience of 5 years in Anand Niketan College of Anandwan, which is situated at Varora, a premier institute run by renowned social worker Baba Amte. And since from 2009, he is working in Department of Chemistry, Savitribai Phule University, and he is now an associate professor. Talking about his educational qualification, he has completed his postgraduate from in organic chemistry as a special subject from Government Vidarbha Institute of Science and Humanities, Amravati. Dear participants, he has qualified SET exam in 2003 and then he qualified NET LS in 2004 and add to that he again qualified NET JRF in the same year. Then he received his prestigious PhD degree in 2016 from Savitribai Phule Pune University. All his qualifications are became things of the past. Let me tell you that he is very active researcher in the field of science and research. So far, he has 14 research publication in reputed international journals, and he has one patent in that is received that is granted in 2021. A patent on an efficient industrial manufacture of sodium alkoxide. It relates structure of the reactor and innovative method. Dear participants, he has so far uh, has ongoing and completed research projects. There were three research projects, and very let me prominently, I want to say that he has two awards to his name. First one is he received Best Innovative Teacher Award in 2021 from Savitribai Phule University and received a gold medal during the last year. Okay, then he has second prestigious award for developing innovative model for effective teaching by National Academy of Sciences of India in 2016. So, with this brief introduction, we are very happy to welcome you, sir, in our webinar. Am I audible, sir? Sir, please turn on your microphone.
Yes, you are audible, sir.
So, I welcome you, sir, on behalf of J.A.T College, J.A.T Management and Organizing Committee of this international webinar. Please join us, sir, and start. Please share your screen.
So I think I'm audible to all.
Yes, sir, you are audible.
Yeah, okay. So thank you for the elaborate introduction. I think Adil has literally told everything about me. Okay. Before starting, I would like to tell you one thing. I'm facing two important problems on my at my end. One is some construction work is going on just beside my cabin, and I can't help avoiding that. So you may be getting certain noise meanwhile I will be talking. Second thing, the university Wi-Fi network is not much stable, so I have connected my laptop with my mobile phone, and I hope so that will support throughout this lecture. Okay, let me share the screen with you. Okay, so somebody please prompt me whether this is visible to you or not.
Yes, sir, it is visible.
It's visible. Okay. Yeah. Okay. So this is a very different topic I'm going to deal with. That introduction of or introduction to the microcontrollers and microprocessors in the chemistry. So I started working with this particular topic since last 2 years, and I'm working with this one, and with the help of this particular topic, I could develop a few instruments in the chemistry, and I thought that with the I should introduce this particular topic because this topic is easier and this topic is a bit new. Because you see what is happening nowadays, that we are heading to the researches which are being done by the prominent people in the chemistry. So maybe it is the organic synthesis, heterocyclic chemistry, carbohydrate chemistry, and there is a lot of research going on in these fields. But the problem is that we may not be suitable for this particular field. Our laboratory may not support for this kind of the research, or we may have different type of the problems associated with such kind of the research to compete with them. So rather than let us find out a new area of the research and let us go get into it, isn't it? So I'm going to talk about this introduction to the microcontrollers and microprocessors in the chemistry and what are the applications. Uh, Before that, before moving to the main topic, let me elaborate. Let me tell you that what we have been doing in our laboratory since last few years. So this is the molecule being synthesized. Just a minute. Yes. So this is the molecule being synthesized in my laboratory, and we have started synthesizing this molecule from the carbon molecule that comes from the mint leaves, and we are now landing on to this particular molecule. The synthesis process is going on. We are just we have done almost 80% of the work. So our laboratory is particularly dedicated for the organic synthesis. This is one more molecule epibetadine that we have synthesized in our laboratory. This is Professor E.J. Kore's synthesis, Nobel laureate Professor E.J. Kore's synthesis. And this is what synthesis we have done in our laboratory. We have landed on the same molecule, and this is a formal total synthesis of this particular molecule we have completed in our laboratory. Besides that, there are certain green chemistry work is going on. So green alternatives for the traditional lab methods. So whatever the traditional lab methods are there, we practice in our laboratory. We are trying to replicate those methods in some advanced ways. Okay, for example, drying of the organic solvents, removing the moisture. So we are trying to do it with the help of certain other and more advanced ways. Okay, because you know, for drying of the solvent, sodium metal is used, certain hydrides are used, certain or costly desiccants are used. Okay, and the effectiveness of this desiccant is often less. So we are trying to find out more advanced methods for doing these kind of the researches. We have also developed certain kind of the instrument. For example, this is the chlorine gas generator and the HCl gas generator. We have done such kind of the instrumentation in our laboratory, and with the help of microcontroller and microprocessor, we are controlling these instruments. And these instruments are fantastically working in our laboratory. I can say that these instruments are providing more output as compared to the traditional methods. Okay. These are the few small instruments that we have developed in our laboratory. This is this 3-stage magnetic stirrer, which would continue to work even after the discontinuity in the electricity. It is having a battery backup, and these instruments are too inexpensive that one can design, one can fabricate in the laboratory, and can use them to sustain the research in the laboratory. So this is a new kind of the instrument, that is the stirrer instrument that we have developed, and it literally runs on a mobile phone charger. This is one instrument developed in my laboratory, which actually used for verification of the Faraday's law of electrolysis. Faraday's first law of electrolysis, second law of electrolysis can be verified with the help of these instruments. And these are the very cost-effective instruments, isn't it? So why we are doing so? So there is some certain problem. Okay, and what that problem is? So there is a question on the screen that what problems we face while engaging into the scientific research, and what frustrates us, isn't it? So engaging into the scientific research is not a simple thing. It needs a lot of patience. It needs a lot of expenses also. It needs infrastructure also, isn't it? And there are many points where we get frustrated. Okay. So what are these points? So most important, we need a research topic. The second thing is that we need the lab. Third one, research funds we need, because scientific research is not a simple affair. It is a costly affair. Chemicals are costly, solvents are costly. Then we need research equipments, and most of the research equipment India is buying most of the research equipment from the European countries, isn't it? This is one more problem, that these equipments are often costly. They need lakhs of rupees for buying them, isn't it? And one more thing is that after doing the research, whatever the research must end with certain publications. So publications are also important for us. Okay. So how to cope up with those all things? Okay. So look at the screen. So do you recognize this particular face? This is an eminent scientist. Okay. And the name of this scientist is Thomas Alva Edison. Okay. So you just remember whatever the point I have raised here, whatever the questions I have raised here, how many of the following facilities were available to him? Whether he was having a research topic, yes, he established the research topics on its own motive, on his own motivation. Second, was he was having a good or sizable laboratory. A train was actually, he established or he converted a train bogie into the laboratory, into a laboratory, and he started doing his research there. And there is a famous tale that he once put on that bogie on fire and everything was caught. Then research fund, where from he got the research fund? He initially sold candy, vegetables, newspapers, isn't it? So this was the starting, how he started with doing these researches, isn't it? So he's actually sold candies, vegetables, and newspaper. See the passion. Then the research equipment. Many of the research equipment needed for his research he developed on his own. Okay, so electromagnetism, for example, he was working on the electromagnetism, so he devised the electromagnet on his own by winding the copper wire around certain ferrite materials, isn't it? And research publication, if you think about the research publication, you see he is having nearly about 1100 patents at his disposal, at his credit. So this is how the scientists actually work. Okay, and I'm very happy to say, and I'm very confident to say that we all have Edison spirit within us, because we are facing different problems, but then also we want to continue with our researches. That is one more thing that I would like to tell out of this slide. Okay, now I have populated a few slides here. And these slides are actually taken from the Journal of Chemical Education, JCE. This JCE is the American Chemical Society Journal. And you see what they have done and what research publications have arrived, have been published so far. Okay, so one article, fabrication of an economical Arduino-based uniaxial tensile tester. So what they have done, they are having a material for which tensile strength has to be measured, and they have made an instrument to measure the tensile strength of the material, isn't it? So these are the photographs of the instruments. Okay, so there is a name, that is the Arduino here. Okay, so just see how many times this term is actually being repeated. Now, design, fabrication, and optical characterization of low cost and open source spin coater. You know, for the FESEM, spin coater is essential. Spin coater is very, very expensive instrument. I think this is costing nearly about 3.5 lakhs to 4.5 lakhs rupees. Okay, and one person has developed a cost-effective spin coater in his laboratory with the help of what? A simple open source boards. Okay, so this open source board is nothing but the Arduino that I have shown you earlier. Okay, so spin coater. One more thing, an inexpensive open source USB Arduino data acquisition device for chemical instrumentation. So when we carry out the chemical reactions, when we carry out certain experiment, we need to populate the data. We need to acquire the data. Okay, and that data can be acquired by certain instrument like detectors or data loggers. So a simple data acquisition machine can be made in the laboratory with expense of a small amount, isn't it? So this is the board. We can use it in the laboratory and we can populate, or we can acquire data, and we can actually automate our reactions and the experiments. Okay. Another thing, design and construction of low-cost Arduino-based pH sensor for the visually impaired using universal pH paper. Okay, so what they are doing, they have developed a pH sensor for visually impaired people, and the Arduino is again in the picture. Okay, see all these whatever I'm talking about. No, this is in relation to the development of different type of the instruments. Okay, and Arduino-based talking calorimeter for the inclusive laboratory lab activities. So they have developed a calorimeter with the help of what? The Arduino. Okay. Then AI means artificial intelligence, Arduino, on demand of atmospheric secondary organic aerosols. So they have again developed one more instrument to measure the organic aerosols present in the air, isn't it? So this is again the environmental chemistry. They are dealing with simple instrumentation. Then separate Arduino designed for the fabrication of a low-cost Arduino-based microcentrifuge. So again, this author has developed what? A microcentrifuge using a Arduino, isn't it? So these people are developing different kind of the instrument with the help of the Arduino, and the Arduino is nothing but a microcontroller and microprocessor for which we are going to learn about. Okay. Now, building a microcontroller based potentiostat. You see, the potentiostat is an expensive thing in the electrochemistry, but with the help of Arduino, they have designed a novel potentiostat and they have used it for the electrochemical reactions. Then cost-effective wireless microcontroller for internet connectivity of open source chemical devices. Isn't it? So there are so many papers are being published in this area. Okay, and there are a few people are working in this area, isn't it? So we need to learn this, and let us learn about the microcontrollers and microprocessors and their application in the chemistry. The application of these microcontrollers and microprocessors are not limited up to chemistry only, but these are having applications in any sciences or all sciences. You can literally implement these boards in any scientific experiments. Okay, so let us move on that. Instrumentation is an essential scientific experience. Instrumentation is an essence of scientific experiment. Whenever we want to do certain research, we have to do the experiments, and for that instruments are essential things. Okay, so we need instruments. Now see, there are certain instruments. This is a very simple instrument. Plier is shown. This is called a mechanical instrument, isn't it? Drill, electrical drill. Okay, so this drill machine is also an instrument, but is electrically operated instrument. And there are certain instruments which are electronically operated instrument. And you see, the electronically operated instruments, they have a large capacity. They can do anything. For example, you just imagine that our computer can literally do anything, isn't it? It is connecting me with you. It is connecting me with a lot of people, isn't it? And similarly, computer can control the major machines like the NMR machines, MRI machines, even the robotic surgeries are there. So electronic instruments is becoming the need of all type of the scientific researches. Okay. Now, what is the purpose of instrument? Purpose of instrument is to unleash the capabilities of humankind. Whatever human cannot do, that to enable human to do such kind of the things which fall out of the human capacities. So such type of things can be done with the help of instruments, isn't it? So it adds to our senses, is add to our capabilities. This is an electron micrograph of the Salmonella typhim invading human cells. So typhoid bacteria, they are actually invading. Human being would not have been in position to observe this type of the event without the instruments. So means is type of the microscope, electron microscope helps human to do this. So instruments are very, very essential in the scientific experiment. One more importance of the instrument, because of which we use smaller instrument, for example, a small data logger we use in the laboratory. Why we use these instruments in the laboratory? There is a different reason. See here, the accuracy of the humankind. If you have started noting down certain parameters in some reaction, then your accuracy might go down with the time, isn't it? So this is called human diligence. And human diligence often goes in declining state. And at one particular time, the time comes where we are not in position to work at all, isn't it? But instruments do not suffer such type of the problem. The accuracy of the instrument always remains uniform irrespective of the time, and that is called the diligence. And for the diligence only, we are using the smaller scientific instruments, isn't it? For example, a data logger, if you set a data logger for counting the CO2 concentrations in the atmosphere, it will continue continue counting the CO2 concentrations for a long time. Not only for the days, but for the years together, the instrument can work, isn't it? So as compared to the human being, the instrument always have a higher diligence. Okay, so for the sake of diligence only, we go for the instruments. One more thing, that there are two kinds of the instrument. There are manual instrument which we need to operate manually, and other kind of instrument are the automated instrument. Automated instrument means once you feed some data, or once you feed a set of instruction, these instrument will continue on their own. Human interference is avoided. Human attention is avoided, isn't it? So not required. Human attention is not required. They can start working on their own. For example, auto samplers, they will the auto samplers work on their own, isn't it? So automation can be introduced, and this helps in the instrumentation. This helps in the experiment. Okay. Now let us come to the cost of the instrumentation. For even a simple experiment, suppose we have to note the temperature variation in a particular reaction. Then what we need? So we need a flask with the reaction. We need a temperature probe, means thermocouple we need. The thermocouple has to be connected with the data logger. Okay, and data logger has to be connected then to with a computer. It may be laptop, it may be computer. And if you try to find out what will be the cost going to be, what is the cost going to be, isn't it? You see here, the data logger is simple, and very simple kind of the data logger is costing around 2 lakhs rupees. A computer would cost nearly about 60,000 rupees. So 2,60,000 is the initial investment we need, isn't it? Okay. So instruments are expensive. So there was a question, can we replace this instrument with simple type of the assemblies by certain simple arrangement, isn't it? And yes, nowadays there are certain ICs are available in the market. For example, you see this kind of the ICs are there. These ICs can be programmed, and these ICs can be made to work according to our instructions, isn't it? So you see here that is, there is a RST1. This pin is means reset pin. There is a D0, D1, D2. These are D4. These are the digital pins. VCC means we can feed a positive supply here. Ground means we can provide a negative, means a power can be fed across this one, isn't it? And there are X1, S2, D1, D5. So many pins are there. And one particular pin from this IC can be made to work as per our instructions. Okay. And simultaneously, since there are multiple pins, we can operate, we can control several things simultaneously, isn't it? So these ICs are nowadays available in the market. And these are very cheap also. Recently, one IC is most catching popularity, and that is called Atmega 328P. So this is one IC. This is the IC, and this is a picture of the IC. See the dimension, 3.28 mm into 37.4 mm into length. Okay, so length is 37.4 mm, means just 3.5 centimeter. Okay, and 3.28 mm width. Okay, and this is the IC that we can use. We can program it and we can use it in our experiments. This IC comes in different forms. So this is again one different form. You see how small it is. It just occupies, means its area is just equal to a tip of our finger, isn't it? So it's a very, very small IC. And nowadays, these ICs are popular, and they are being used in different type of instruments. Okay. Now, what is the problem with those ICs? These are microcontroller ICs. These ICs are called as the microcontroller ICs, but there is one problem associated with this IC. Microcontrollers and microprocessor chips cannot be programmed without putting them into a complex circuit. So before using these ICs, we have to design a circuit. We have to put that IC into the circuit, and then we have to use those ICs, isn't it? Hence, hence there is a problem that everybody is not well versed with the electronics, isn't it? And hence there is a problem of the versatility. And therefore, certain boards are nowadays available in the market, which are ready-made board. We can buy them and we can program them, and we can make those boards to work as per our instruction, isn't it? So here comes the Arduino. Okay, so Arduino is the name of the brand. Okay, and they have developed such kind of the boards which can be easily programmed and which can be configured into an instrument, and we can use this board for our experiment. Okay. For example, you see here, this is a micro chip that Atmega 328P. So Atmega is the name. Okay, 328P, this is the number of the chip, and see what is the configuration of this. You know, in our computer also, there is CPU. Okay, there is a memory. Okay, there are hardware also. Okay, so in this IC, there is a memory, and it is also a CPU. It is working, it is providing the facilities, or it is providing the capabilities of a CPU as well as a memory. Okay, you see the CPU type it is 8-bit AVR. My laptop or your laptop is working at 64-bit, and this IC works at 8-bit, isn't it? The maximum CPU speed is 20 megahertz. 20 megahertz. So you see, this is a large speed actually. Performance 20 MIPS at 20 megahertz. And flash memory, it is having internal memory of 32 kilobytes. 32 kilobytes. This is a small memory, but this memory is sufficient to burn a program, to hold a program. It is also having a static RAM, that is 2 KB. It is having erasable programmable memory of 1 KB. Okay, so this comes in a very small package. Okay, look at this person. This person is Hernando Barragan. Okay, and this person means he was developed this particular circuit as a part of his MSc project and then as a part of his PhD dissertation. Okay, and this simple circuit then grew up and taken shape of a circuit, and that circuit is known as the Arduino circuit. Okay, now see this, the team came in and they just modified this particular circuit. They put all these components on a single board and made a ready board which can be directly connected to the computer and directly programmed. Okay, see here, there is a statistics given how many boards they prepared and how many boards they actually sold into the market. So in 2011, the number of boards sold were 3 lakhs. And in 2013, the number of boards sold were 7 lakhs board, isn't it? So these boards are now famous because of the 2 reasons. One, because of their capabilities, because of their program, their easiness, and because of their cost effectiveness. Cost effectiveness means what? One particular board, if you want to buy from the Amazon or if you want to buy from the e-commerce sites, then it costs only 350 to 450 rupees. And you can develop a good instrument out of it. Okay. So what are the boards available, or what are the boards, or what are the platforms available nowadays on the Amazon or e-commerce sites? Okay. You see, this is the smallest board available. This board is having size of a credit card. Okay, so this is just a credit card size or ATM card size. And this board is costing nearly about 350 to 450 rupees. Recently, there has been a problem that China has stopped or made a artificial scarcity of the ICs, and therefore the prices have boosted up. Maybe this is now costing 600 rupees. Okay, so this is Arduino Uno board. This is Arduino Nano board. This is very, very small board. This is Arduino Leonardo, this Arduino Micro, Arduino Nano, and this is again different type of the adapter. So these type of the platforms are readily available nowadays, and you can buy those platforms. This is the USB cable means adapter. You can directly hook it to the computer, and with the help of certain programmers, you can program these boards and you can use them for different type of the experiments. Okay, so let us begin studying boards one after other. I will be flashing certain pictures on the screen and I will be explaining in the brief. It is not necessary to understand each and everything. At the first sight, you may not be understand all those things of how to use this board, but just keep in your mind that we are actually being introduced to a new kind of the knowledge. Okay, so this particular board is Arduino Nano board. Look at the size. This is very fine. Means on the screen it might be appearing very large, but the size is very, very small. Okay, and what is the voltage operation? It operates at 3.3 volt to 5 volt. Means literally a mobile phone charger can be utilized to run this board, or a mobile phone battery also can be used, or a power bank can also be used to power this board and make it function. Okay, so this is having a 3.3 volt to 5 volt microcontroller board. You can see here there is an Atomic IC, there is a reset button, and there is a USB adapter given here. So with the help of USB adapter, it can be programmed. Then see here, the certain pins are there. So D2, D12, D11, D10 up to what? So D2 pins. These are called digital output pins. Means you can program these pins from this IC using the USB, and you can make these pins to work according to our wish, isn't it? There is a reset button, a reset pin, and there are certain analog pins. So for example, A0, A1, A2, A3. These pins are called general purpose input output pins. Okay, and from the analog pin, we can give different type of the inputs, analog input. For example, if you want to measure a temperature, you can make this A2 pin to work as a temperature measurement, configure as a temperature measurement. Okay, configure for the temperature measurement. So it will sense the temperature, it will sense the analog signal, it will process into this one, and it will send the output to some certain configured pin, and that can be read with the help of other devices. Okay, so this is a very, very smaller board. What is the weight of this board? 7 grams. you see the weight of this board is only 7 gram. Okay, and dimensions are also written here. It is having a microcontroller Atmega 328. So the same chip is there. It is AVR designer. Operation is 5 volt. Flash memory 32 kilobytes. SRAM is 2 kilobyte. Okay, clock speed 16 megahertz means this is a fair speed actually. Analog pins are 8. So this is the configuration. With a small board, you can do a lot of work in the chemistry. You can automate your chemistry experiments. Okay. Another board is Arduino Micro board. Okay, so the board is a little larger. It is having a again bigger IC. This is Atmel IC is having on, and the weight is 13 gram. So this is also a microcontroller board with Atmega 32U4. Okay, so this is the name of the IC. Okay, again the weight is 13 gram, and what is the microcontroller? Atmega 32U4. This is operating voltage 5 volt. 5 volt is very famous voltage because nowadays all the mobile phones are operating on the same voltage. Okay, input voltage recommended is 7 to 12 volt. Input voltage limit is 6 to 20 volt. Okay, and it can be again configured with the USB device. And this is again a very small board. You see the length of the board is 4.8 centimeters by 1.8 centimeter, means 18 mm by 48 mm. This is the size. So these boards can fit in any instrument in a small place, and this can be configured with the help of, this can be programmed with the help of a computer. Okay. Now this is the most famous board. Its weight is about 25 grams. Okay, and it is available every now and then. All the e-commerce websites are actually marketing this one. It is having, this is the chip. This is the 12-hole jack, means you can connect it to the battery. This is the USB. This is the reset button. Okay, and this is the board actually. And these are the connectors. You can connect these different pins over here. Okay, so it is having a flash memory of 32 kilobytes Atmega. Then SRAM is 2 kilobyte. Then it is having a EEPROM of 1 KB. It is having a clock speed of 16 megahertz, and its length is 68 mm by 53 mm, and total weight is 25 grams. Just a pocket size or credit card size board, and this board can easily configured and can be used in the laboratory. Okay. I'm giving a little more information about this board. See here, this is a reset switch. So with the help of this switch, you can reset the program. Means if you press this switch, what will happen? Whatever the program you have burned into the IC, that will come into play once again. Okay, so you can reset this one. So it can reset this board. Okay, there is a USB connector. So this connector adopts the USB output, and that can the other end of the USB cable can be connected to the laptop, and this IC can be programmed. Okay. Then there is a USB interface chip. Okay, so actually this USB interface chip talks or mediates between the laptop or the computer and this particular chip. Okay, then there is a crystal oscillator. So this besides the clock speed of this particular pin, there is a voltage regulator. Means if you want to feed 12 volt in and board wants a 5 voltage, then that volt is converted by this particular regulator. There is a voltage regulator. Okay, so this board can be made to run on 5 volt as well as the 12 volt. So this is the microcontroller IC. This is analog input pins, means you can provide different analog inputs, like the, suppose you want to measure potential generated in a electrochemical reaction. You can input that potential here, and its digital output will be given on the digital pins. Okay, so this is what general structure of the Arduino Uno board. There is one more board that is capable of being connected with the Wi-Fi. Okay, so this is the Arduino Uno board, but it is a Wi-Fi version. So it can directly get connected with the Wi-Fi, and you can transmit the data on the network. You can store this data somewhere else if it is connected with some data syncing websites. Okay, so it is again having a microcontroller Atmega 4809 IC on it. Okay, and this is again a new kind of the Arduino board available, and the price is maybe around 1,000 rupees. Okay, so see what benefit we are getting. We are getting the benefit of the microcontroller. Then we are getting the benefit of the Wi-Fi also. Okay, and data transmission is possible with the help of this board. Okay. There is one more board with improved capabilities that is called Arduino Leonardo. Okay. And all these boards are available online. You can buy these boards just sitting at your place. Okay. Weight is 20 gram. And you see, these are the digital pins. These are the analog pins. These then USB interface and 12-volt interface. This everything is there. Okay. Just a minute. Yes, sorry. Now there are certain major boards available in the market. This is called Arduino Mega Board. So what is Arduino Mega Board? In Arduino Mega Board, it offers making large circuits. It allowed making large circuits. Suppose one particular circuit needs more than 54 GPIO pins. You see here, it can offer 53 connections here, and it can offer at most at least 20 connections here. So large boards or large circuits can be made with the help of this board. This board is called like the Arduino Mega Board. Okay, so I have used this board in many experiments, and it's very easy to use this particular board. Okay, now how these boards can be programmed? It's very easy. Go to the website, download a program that is called Arduino IDE. Interface this Arduino with your laptop, and you can run a particular program. You can compile the program in the Arduino IDE, and after completing the program, this program can be burned into the IC of this board with the help of the USB interface. Okay, so all this is possible instantly, and Arduino board is cheap, and this Arduino IDE is actually a freeware you can download for free, isn't it? And you can program it. Yes. So this is the picture of the Arduino IDE. When you start the Arduino IDE, this is the picture comes on your screen. This is the button right where the right button is shown. This actually checks whether your program is correct or not. And if your program is correct without any error, then you can hit this particular button. You can click this button and the program goes into this IC. It takes only a few seconds, only 10 seconds it takes to burn a program, a sizable program. And once the program is burned into the IC, into this IC, you can detach this board, then you can power in this board, and this board starts working on its own. Computer is not required hereafter, isn't it? So in this way, whatever program you made, that program can be burned into the IC, and itself it starts working as an independent unit, So these are the different kind of the USB cables you need for connecting this board to the device, the laptop. But it's very easy. This is the printer cable, and you can use this printer cable to interface this board with your laptop. So this is called Arduino IDE. Then Arduino Android IDE. So suppose you don't have a laptop with you, because laptops are many times expensive, and mobile phones is the device everybody have. So you can interface this board with the help of what? With the means mobile phones. You can program using mobile phone, and you can burn this program with the help of mobile phone into the memory of the boards. So there are Arduino Android available. You can download for free, and you can start working on these. Yes. There is one more very specialized board available in the market that is called LilyPad. LilyPad. It is also having a Atmega 328 wearable board. You see the size of the board is just 5 centimeters, and the thickness of the board is 0.8 mm only. So this is a very small board, and it is having an IC on it. This board can be programmed, isn't it? And this board can be fitted on the clothes. And this is a prominent board people are using nowadays for in the fashion industries, okay, and in a variety of the applications, isn't it? So you see here, this is the Arduino Lily board, okay, and these boards can be used. This board can be programmed with the help of very small adapter. Okay, this adapter comes for 100 rupees. The board is for 400 rupees. So at the cost of 500 rupees, you can start working with these boards. There is another variation of this board, because these boards need an adapter, because this board can interface, it can be interfaced directly with the computer with the help of USB, isn't it? Because the USB operating chip is installed on this board. So this is called LilyPad. Okay. See here, what is the size of the board? The weight of the board is 10 gram only. And it is having a microcontroller Atmega 168 or Atmega 228 feet. Okay. Operating voltage is 2.7 to 5.5. This is very, very small voltage. 2.7 volt, this voltage can be obtained by a pair of cells. Pair of cells means what? Means pencil cells. Okay. Input voltage 2.7 to 5.5 volt. Digital pins, it is having 14 digital pins output. You see whatever the holes shown here, these are the digital pins. A4, A3, A2, A1, these are the analog pins. Remaining pins are the digital pins. Okay, so you can use the digital pins to execute a particular function. See here, this board is actually put on a handkerchief. There are LEDs shown. Okay, and this is now the fashion industry is now using this board for a variety of the purpose. So see this with this model. This model has fitted this Arduino lily pad on the shoe, and she might be using it for some reason, isn't it? So this is now a new industry is coming up that is called e-textile industry, where LEDs would be fitted on the saris, LEDs will be fitted on the textiles as a part of fashion. Okay, yes. So this is about the Arduino board. So altogether, what is the scenario? Scenario is there are there are several kind of the board available in the market. So Arduino Nano, Arduino Mini, Arduino Uno, then Leonardo, then Arduino Wi-Fi, Arduino Mega, Arduino Pad, everything is available. And we can use this board in our chemistry to execute, to control the experiment, to read the experiments, to log the data, to execute the experiment, isn't it? So this everything can be used, or these boards can be used for different type of the experiments in the chemistry, isn't it? Now, what is the general structure of the automated instrument? Till now, what we have seen what kind of the boards are available and a little introduction about it. Now, what is the general structure of the automated system? So you see, there is a system that is called transducer, which generates the signal. The signals are actually fed to a data logger, and then data logger generates a readable output that is called a graph. Okay, so this is what a general structure. So there is an electronic signal generator. Means suppose we want to measure the temperature, we need a temperature sensor. Okay, then there is necessity of the signal processing unit, then data acquisition unit. Both unit together, these are called as the data logger. Okay, and the data recording system we need, that data is actually recorded on the laptop or on a mobile phone, isn't it? So we need a computer system, we need a GUI software also. Okay, suppose we replicate this experiment with the help of Arduino, what will be the total cost? You see, this is a simple data logging experiment that we are logging the temperature only, and it is required about 2.6 lakhs rupees. Suppose we translate this experiment with the help of Arduino, what will happen? Okay, so this is temperature sensor. This temperature sensor is costing rupees 15, or it is costing rupees 10. If you go to any simple shop, you can buy this temperature sensor at the cost of 15 rupees. Expensive most. And if you buy in bulk, means in 10 or 20 pieces, you will get for rupees 2 only. This serves as a temperature sensor. Now you see, this is temperature sensor. Our chemical reactions are carcinogen, or temperature or chemical reactions are corrosive. So you can put this temperature sensor in a glass tube and use as a thermometer. Okay, so this is the temperature sensor. These wires are coming out. These wires are fed to the Arduino. Okay, the Arduino is programmed, and this there is a memory card. You can either interface with the memory card, or you can get this data on the memory card, or you can get this data on the laptop. Altogether, the experiment is costing 1,000 rupees only. 1,000 rupees only. You see how we can kill the cost of the instrumentation. This is how we can kill the cost of the instrumentation, and we can redesign or revisit our experiment for the cost-effective manner. Okay. Now, as we have seen all those things, but there are certain limitations and shortfalls of the microcontrollers. Okay. What are the shortfalls of the microcontrollers? One, it is generally utilized in micro equipments. For example, microwave ovens, washing machines. Okay, for such kind of simple instrument, the microcontroller can be used. It has a complex structure. Yes, microcontrollers do have complex structure because it has a microcontroller with several pins, and it needs to be embedded in an electronic circuit. But we need not to make the electronic circuit, because those electronic circuits are already available in the market. with the microcontrollers, and that we have seen. Microcontroller cannot interface a better power device directly. Okay, cannot interface a better power device directly. This microcontroller you cannot directly interface with the other device or better power devices. Okay, you need a circuit for that. Then number of executions is limited. For example, if you want to run one particular program, microcontroller can handle one program at a time. It cannot handle more than many programs at a time. Okay. Okay. As every microcontroller does not have an analog input output, there are issues. And every microcontroller need not to have an analog input output system. But you see, whatever board we have discussed so far, all are having input output devices, input output analog pins also. Okay. So these are the shortcomings of the microcontroller. Now let us have one loop between what is the difference between the microcontroller and the microprocessor. Okay. So I'm not going deep into this particular table, but I will tell you, when you want a very small experiment to be executed, you can go for a microcontroller, isn't it? For example, you have to read the data from some reaction, or one or two parameters only you are reading, you can go for the microcontroller. But simultaneously and very rapidly, you need to populate a data, a large data you want to handle, then you need a microprocessor instead of a microcontroller, isn't it? You see, earlier our mobile phones could have microcontroller, but now the mobile phone capacity has gone up, and now they have the microprocessors inside, and because of which the ability of our mobile phone has gone equivalent to the tablets, equivalent to the laptops, isn't it? So the higher capacity comes from what? The microprocessors. Okay. Now see how the microcontroller and a microprocessor differ from each other. There is a simple illustration on the screen. Microprocessor can execute one statement after other. In a sequence only, it can execute the statement. Okay, but microprocessor can handle several instructions simultaneously, and therefore it is having more complex structure and more capabilities. So microcontroller is a daemon actually, and microcontroller is a very small gene that can serve our purpose, isn't it? So for smaller program, we can use microcontroller. If the program is very high, or if the process is ultimate process is required, we can go for microprocessor. Okay. Now there are certain boards you might have heard about, a name that is called Raspberry Pi. So again, those names are there in the picture, and Raspberry Pi circuits are also nowadays available in the market. Okay, you see, the microcontroller boards are cheaper. Microprocessor boards are little expensive. Little expensive means what? A good quality microcontroller board from the Raspberry Pi comes for 3,500 rupees only. Okay, but it is having a large capacity. You can literally make a computer out of a simple Raspberry Pi board. Okay, so Raspberry Pi boards are the microprocessor boards manufactured by Raspberry Pi Foundation in UK. Raspberry Pi Foundation in UK. Actually, this is the foundation started to help the poor countries, because poor countries would not have computers at their disposal for the digital learnings. And Raspberry Pi Foundation started this particular project, and they prepared small boards, isn't it? You see here. Dear Adil sir, hello.
Yes, sir.
Yes, sir. Is there any time constraint, please?
Yes, sir, you can continue.
Okay. I will take a little bit time. Okay. So in between, if you feel, you can stop me in between. Okay. Yeah. Okay. So this is one more piece. You see here, this is the microcontroller from the Raspberry Pi. Okay. Again, you see, Raspberry Pi produces both kind of the boards, microcontroller boards as well as the microprocessor board. So this is a microcontroller board from the Raspberry Pi. Okay. And it is having more capabilities as compared to the Arduino. But again, this is a microcontroller board. And what is the cost of this board? Recently, I bought this board for 350 rupees. And it is available on Amazon. You can easily buy it. And you can start learning programming with the help of this one. Okay, so again, this is a similar kind of the board to that of the Arduino. Okay, so you see what is in it. So this name of this board is Raspberry Pi Pico. Pico is the name of this board. People call RPi Pico, generally abbreviated as RPi Pico. So this RPi Pico board is having Raspberry Raspberry Pi 2040 microcontroller. So dedicated microcontroller is there on this board. Okay. Yes. It is a dual core ARM Cortex. So this is dual core. You know, the laptops also nowadays they are having dual core processors, isn't it? So this is the dual core ARM Cortex M0 processor. The flexible clock running at 133 megahertz. You see, Arduino provides 16 megahertz clock, but now this board provides 133 megahertz clock. So this can perform the execution, or this can handle the program very fast. Okay. Now it is having 3.264 KB of SRAM, 2 MB onboard flash memory. It is also having flash memory. Its size 4.26 multifunction GPIO pins are there. So these, whatever the holes you are looking at here, so these are the GPIO pins. Okay, so this is a microcontroller on the Raspberry Pi. Another Raspberry Pi board is there, that is called a Raspberry Pi Zero. You see here, whatever the board we looked here, that board is microcontroller board, not the microprocessor board. But now let us move to the microprocessor board. So the name of this board is Raspberry Pi Zero board. Okay, so you see what are the capabilities of this board. Now this board is having, these are the GPIO pin, means general purpose input output pins. Means these pins can receive instruction, these pins can transfer instructions. Now see here, this particular slot can hold a small memory chip. So you can put the memory chip here, memory card here. So if some data has to be stored, this data is stored on this memory card. Now it is having a HDMI interface. This HDMI interface means you can put a plug over here, HDMI, and another end of the this cable can go to your television, can go to your monitor, where you can see the process happening here. You can see the data there. Okay. It is having a microprocessor here, microprocessor board here, microprocessor IC here. Okay, and you see here, there are USB outputs. There is a DSI port, means you can attach a camera, and it offers all type of the function. It offers all type of function. So you see what is here in the package. It is having 1 gigahertz single core CPU. So this is a CPU actually, central processing unit, has 520 MB RAM. 512 MB RAM. It's having a random memory of 512 MB. It is having a mini HDMI port. So see here, there is a mini HDMI port. So it can simultaneously become attached to two different monitors. Two different monitors is simul. Okay, it can become attached to your television also, and you can make a computer out of your television. It is having a micro USB power port. So micro USB power port is also there. It is hat compatible, means different type of the hats are also available. So it is nothing but a micro processor board, and the cost is around 1200 rupees. Cost is 1200 rupees. So it is very cheap board available in the market, which is having enormous capabilities. It can process the audio, it can process the video, as well as it can process the data. It can be programmed, it can execute many programs simultaneously. So it is a sort of microprocessor board called Raspberry Pi Zero. Okay, what are the components of the Raspberry Pi Zero? You see, there is a Wi-Fi 802, Wi-Fi and Bluetooth is also available. Micro SD card is there where you can put the memory. Mini HDMI port is there, so you can put a HDMI port here. Micro USB port is there. Okay, then micro USB 5-volt power input, you can power this board with the help of this port. There is a RCA compatible video output, means you can interface it to the video adapters. Okay, and you can these are the different type of the GPIO pins. Okay, GPIO pins means what? General purpose input output pins, means these pins can receive the data, these pins can transmit the data. Okay, so this is what the structure of the Raspberry Pi Zero. Okay, now more importantly, this is a very different kind of the board. This is called Raspberry Pi 3B Plus. Raspberry Pi 3B Plus. The cost is 3.5. Now, means 3.5. Yes, 3,500 rupees. Okay. Again, what are the components you see here? This is USB. Means suppose you want to interface a mouse with it. Yes, USBs are there. You can interface keyboard with it. Okay. There is a LAN adapter, means you can put a LAN port here. There is a audio jack adapter. You see, you can put your headphone here, isn't it? There is a DSI port, means there you can interface a video interface here. This is HDMI, means you can interface with the help with your monitor or the television, isn't it? And this is what the microprocessor here, isn't it? So this microprocessor board size is just of your ATM card size or credit card size. Okay, and this board is called as the Raspberry Pi 3B Plus, isn't it? One simple thing, Raspberry Pi 3B Plus can become interfaced with a single video monitor, with a single video monitor. It can process audio, it can process video, 4K video, it can process, isn't it? So this is the 3B Plus. There is another version, that is this. These are the specification of the Raspberry Pi. You can visit any website and you can find out the specification. Okay, let us move to the other kind of the Raspberry Pi. Okay, so this is one more board. Recently, I'm working on this board. This board is again the size of what? A credit card size board. Okay, the name of this board is Raspberry Pi 4B Plus. So again, the size is credit card size desktop computer. It is literally a computer. You need not to buy a computer if you buy this board, isn't it? So you see what are the capabilities. So it is having the more powerful processor. So it is having a processor. The choice of the RAM. So this board comes in 3 different forms. That is, one is having 2GB RAM, 4GB RAM, and 8GB RAM. Okay, so the cost goes accordingly, but the cost is not more than 5,000 rupees. Okay, so if you go for a 8GB RAM board, you can buy comfortably within 5,000 rupees. Okay, so this is gigabyte internet. It becomes attached with the internet. Okay, then it is having USB 3 ports. It is having USB 2 ports. So 2 USB 2 ports, 2 USB 3 ports it's having. Therefore, it can become interfaced with the printers. It can become interfaced with the mouse, keyboard, and other similar kind of the devices. Okay, it is having 2 HDMI ports now. See here, there are 2 HDMI ports. So you can attach 2 different televisions to it. Okay, 2 different monitors to it, and you can see different programs on different monitors, different software on different monitors, isn't it? And there is a USB-C, and it literally consumes 5-volt power. Okay, 5-volt 3 ampere means you can energize this board with the help of a mobile phone charger, mobile phone adapter, isn't it? So this is what capability of the Raspberry Pi 4B Plus. Okay, so this is the most advanced board available in the market. See, this is the size of the board. It fits into just hand. Okay, and it got a programmer that is called Raspberry Pi OS. So just like our computer need Windows, just like our computer need the DOS systems to run operating system. So Raspberry Pi is having a different operating system that is called Raspberry Pi OS. So this OS is also free, and you can download this OS on a memory card. And if you put this memory card into this board, without a hard disk, this board start functioning for you, isn't it? So this is Raspberry Pi 4B, isn't it? So there is a programmer called Thony IDE. If you download this Thony, you can start programming with the help of this Thony. So higher level languages can be programmed, and these programs can be stored on this memory card. And when the memory card goes there, you can see the file. Once you double click this file, this program automatically execute, and this program start working, isn't it? You can make a small computer out of the Raspberry Pi OS. So if you have this particular board, this whatever the board I have shown here, this board if you buy, then you can attach this board to a monitor. You can attach this board to a mouse and the keyboard, and yes, your computer is done. Your computer is ready to go, and you can work with a different type of the software. You have the text editors, you have the word processors, you have the data sheet management, slideshows, music player, video player, internet browser, notepad, calculators, Python editor. You can do Python program. You can do literally everything with the help of this one. Just remember, most of the laptops, they do have Windows system to run. This particular board is having Linux system to run, but this is very easy to operate, and it is costly. Suppose then if you are planning to buy the Raspberry, buy a laptop or a PC, then rather go for this particular setup. Okay, this is a screen from the Raspberry Pi desktop. When Raspberry Pi is configured, this kind of the desktop is actually shown on the screen. This is just like a computer. You can use mouse with the, you can operate it with the help of mouse, and it's very easy to operate. Simultaneously, it is a cost effective. See here, this is the Raspberry Pi. This Raspberry Pi has been interfaced with two different monitors, and these monitors are very large quality monitor, or high quality monitors. They support 4K output. So two 4K output monitors can be interfaced with a small board. This is a power bank. With the help of power bank only, you can run and you can make a very good quality computer output, isn't it? So this is about the Raspberry Pi and Raspberry Pi 400. Okay. Again, there is one more computer like that is Raspberry Pi 400. So this particular board is called as Raspberry Pi 4B Plus. Okay. And this is called as Raspberry Pi 400. What is the Raspberry Pi 400? They have provided a keyboard in which this board is packed. Which one? This board is packed inside the keyboard. So you did not to buy a keyboard separately. So there, this keyboard itself is having Raspberry Pi board. You just need to plug a power supply, a monitor, okay, and a power supply, monitor, and a mouse, okay, and your computer is done. Okay. So you see what is at the end, what the backside of this board. So this is the GPIO, means general purpose input output headers are there. There are micro HDMI ports. Okay, there is micro SD port. Okay, 2 into USB ports are there. Gigabit Ethernet is there. USB 2 ports are there. USB 3 ports are there. So this is all together packed computer, and the cost is around I think 5,000 rupees. The cost is 5,000 rupees, isn't it? So Raspberry Pi 400 directly becomes connected with the monitor. You did not to buy a board separately. Okay, so if you buy this particular keyboard, it comes back with that particular processor. Okay, and the cost is 5,000 rupees. Okay, so what you need: a mouse, this Raspberry Pi 400, then a power adapter, and just a few monitor cables. Okay, so with the help of this one, you can build your own desktop. Look at here. So I have made one particular experiment in my laboratory. We have continuously monitored the temperature variations in a chemical reaction for several days together, isn't it? Earlier, we would need this particular multimeter, digital multimeter. This multimeter is costing 45,000 rupees. It was having a battery, and this battery would not sustain for a long time. So we needed a CPU at our disposal. We need a computer system, isn't it? Then we need voltage converters, and all these costed nearly about 2.5 lakhs rupees, isn't it? But with the help of Raspberry Pi and very simple, with the help of Arduino, and with this very simple program, we could do so. You see, this particular experiment, we have replicated with the help of this Arduino board, isn't it? And what was the cost? 1,000. So nowadays, we are using this Arduino board, Raspberry Pi board for development of the new experiments. For dating purpose, for controlling these particular boards in our laboratory, isn't it? Now see, this is a temperature curve we have logged with the help of Arduino board. You see, we have noted, we have recorded with the help of the Arduino board, and you see what is the graph we could generate. So actually, we populated the data. We then put this data into the origin, and we plotted the graph. So temperature measurements, so enthalpy measurement, we can do with the help of this one. Okay, so this particular experiment actually led to a patent. Then we have, with the help of these microcontrollers, we have not only developed the chemical reactions and monitored the chemical reactions, but we also have developed certain chemical reactors with the help of this kind of board. This is a flash chromatographic system that I have developed with the help of the microcontroller board. And this is the one chemical reactor controller we have made for the chemistry, isn't it? So yeah, we can literally control the chemical reactions with the help of this particular unit. So these are the two important equipments that we have designed with the help of this microcontroller and microprocessors. This is one more device that we have designed. It is having a touch screen. It is having a dedicated software, and it is this device is having high-end activities. We are now in the process of making a patent of it, and a few part of this particular device have been already patented. Okay, so this is for the online data communication, means some chemical reaction is going on in my laboratory. I'm sitting with laptop somewhere else. So those reactions are talking to me with the help of an internet. So such kind of the devices we have developed in our laboratory. Okay. So yes, this is one more simple chemistry model that we prepared in our laboratory for the teaching of frontier molecular orbital theory. And this actually attracted a innovative model award in 2016 from the National Academy of the Sciences. This is one more my recognition. In 2021, I was awarded a innovative teacher award. Okay, so with this, let us stop. If you have any questions, you feel free to ask me the questions. So we are stopping here. Thank you.
Thank you very much, sir. The session is open for discussion. So, sir, please unmute on. If any participant want to discuss anything with Natrak sir, please you can raise your hand and you can ask the question.
Yes, Dr. Ajit sir.
Yes,
Uh,
please.
it's Mumin Shehbaz.
Yes.
Sir, I want to ask one thing that can we shift to the IoT instead
Yes,
of
definitely. Yeah.
Arduino?
Yes. Yeah. Why not? You see, this particular. Can you see the screen, please?
Yes, yes.
Yes. So this device is actually an IoT. If you want to shift to the IoT, you need a microprocessor, not microcontroller.
Yes, exactly what I want to ask. That you have told that in microcontroller there is some single program can execute, na?
Yes, my microcontroller single program can execute. Okay, and if your program is very simple, you can, and if the program is very simple, you can still use a microcontroller. Okay, so I have told you about the Wi-Fi model of the Arduino board, isn't it? So if you go for that particular board, you can still use IoT on microcontroller. Okay, let me take you there. Yes, this Arduino Wi-Fi. If your
Yes.
program is very simple, you can connect it to the Wi-Fi. You can sync the data directly on the cloud. You can go for IoT. I hope I have answered your question, sir.
Yes, sir, yes.
Yeah.
But actually, I have one query also. That microprocessor can handle many inputs, as you have told. But
Yes.
nowadays, microcontrollers are used in many more fashions. Sir, what is the reason?
Microcontrollers.
Yes, yes.
Yes, microcontrollers are actually cheap versions of the microprocessor. For example, you see, you have to control a micro oven. So micro oven is not having many programs together. Just you are pressing somewhere and a particular function has to be rolled out. Okay, so this kind of the simple function can be handed over to the microcontroller because microcontrollers are rather cheap, isn't it? Microprocessors, they need external memory, isn't it? You see here, when we were talking about the Raspberry Pi, isn't it? Raspberry Pi needed a memory card, isn't it? And program has to be run on the memory card. One more thing is that microcontroller can be programmed with simple language like the C language, but microprocessor has to be programmed with higher level languages like Python, like Java, isn't it?
Yes, yes.
Yeah.
Okay, sir. So participants can ask the question to Natrak sir on their private email. This is my request because another resource person is waiting for us. Thank you, Natrak sir.
Yes. Thank you.
Your lecture was very nice. Your presentation was really very nice. And thank you for sharing your knowledge and experience with us. And by looking at your achievements, now I am feeling more proudful that we have spent few years together in the Department of Chemistry, SPPU. And your presentation was really sensational. It was ecstatic and phenomenal. Thank you, sir. For the next resource person from Japan, I call upon Professor Padhan sir, HOD Department of Chemistry, for their brief introduction. Please, sir. Thank you, Dr. Sir.
Thank you, Rajesh sir. And thank you, Datak sir also. Now, it is a time for a second resource person. First of all, Pankaj sir. First of all, I offer my special thanks to you for accepting our invitation at the nick of time and getting ready to be the resource person of the program. Now, I'm giving a brief introductions of our second resource person, Dr. Pankaj sir. He had completed BSc in North Maharashtra University, Jalgaon in physics. Then he completed his master degree from North Maharashtra University, Jalgaon in physics with material science. Then he completed PhD again in North Maharashtra University, Jalgaon. And when we talk about the experience of Dr. Pankaj sir, then postdoctoral fellow he is at Korea University in Korea from November 2005 to 2006. He is now presently associate professor and researcher at the Department of Optical Science, Tokushima University of Japan. And sir has published 95 peer-reviewed SI papers, 3 conference papers, 50 presentation in conferences, and 70 invited talks in international conferences, universities, and colleges. And I think this one is the 70th one. So please, sir, please continue your talk. Thank you.
Thank you. Thank you very much for nice introduction. First of all, I would like to thank the organizer for giving me this opportunity to share my experience on the synthesis of nanostructures. My name is Pankaj Koinkar and I'm working in Tokushima University. I'm an associate professor in optical science and I have additional charges of vice director of one of the center. The name of that center is Center for International Research and Educational Cooperation. This is the outline of my talk. First, I will give some information about Tokushima University where I'm working. Then I will come to my topic of two-dimensional material. Basically, I'm working on the synthesis of two-dimensional material for optoelectronic properties. And while doing the research on two-dimensional material, we prepare this material using laser ablation process. So I will explain what is the laser ablation process. Most of you might not heard about this process. So it will be new information for most of the students. Then I will show you some example how we have created a nanostructures using laser ablation. And at the end of the talk, I will give the information about optoelectronic property of these prepared nanostructures. So first, about the Tokushima University. Although my introduction has been given, but still I will explain you in 1 minute. My all education is done in North Maharashtra University, rightly from Bachelor of Science till the PhD. Basically, I am a physicist. And from 2005, I'm working initially as a postdoctoral in Korea, and then I moved to Japan in 2007. Researcher, then assistant professor, and now I am an associate professor. My research topic is two-dimensional nanostructures and laser ablation. We are using the process to produce, to generate, to create these material. Then we see their optoelectronic property or their light behavior using various process, for example, photocatalysis or field electron emission or sensors. These are my publications. And first 30 years of my life I spent in India, and from last 16 years I am in abroad. This is the map of Japan. Okay, so you can see here Japan is made up of 4 big islands. So this big island is Honshu. North part there is Hokkaido, and in south there is Shikoku, and one more island is Kyushu. Tokushima is located here. It is a small island. You can see I have made the circle, and on this island there is a Tokushima. So this is the location of Tokushima. It is 180 kilometers from Kansai International Airport, which is 180 kilometers from Tokushima. And Tokyo is about 700 kilometers from Tokushima. So our nearest airport to reach Tokushima is Kansai International Airport at Osaka. This is the aerial photograph of our university. You can see here is university. This is the river. This is the main administrative building where all lecture can be held for the student. And these are various department, mechanical, biological, chemistry. And this is the building for optical science. Now I'm sitting at the 4th floor of this building. We have basically 7 departments: civil, mechanical, applied chemistry, biological, electronic, and computer. And about 956 teachers, 9,000 students. There are 638 international students, and non-teaching staff is 1,400. We have several collaboration with the different university from Asia, from America, from Europe, and so on. So there are 92 partner university for Tokushima University from 27 countries. Most of the partner university is from Asia. There are 65 university, and out of 65, 4 university from India: Pune University, Aurangabad, then North Maharashtra, and Bharati University. So we have signed MOU with these universities. 2 vice chancellor, one from North Maharashtra University and another from Aurangabad University, visited Tokushima University. Beside these vice chancellor, 92 students has visited Tokushima University for various purposes such as spring school, summer school, international conferences or symposium. And about 29 teacher and dean or registrar, 14, and 5 other people also visited this university in last 12 years. Now coming to the 2-dimensional material. This is our today's topic. How we are preparing the 2-dimensional material. So let's go to the basic first. Okay. What is 2-dimensional material? You might have seen this photo. Some of you, I'm not sure all of the students have seen this, but some of you, if your major is chemistry or physics, you might have seen these photos. These are 2 researchers from UK. And they are working on graphene. So their name is Andrzej and Novoselaw. They got Nobel Prize for their outstanding research in the field of graphene. So they got Nobel Prize in 2010. Actually, they have started the research in 2004. And while working on the graphene, they prepare the graphene in the laboratory and they published first paper on graphene in 2004. And within 6 years, they got the Nobel Prize. So it is very short time. They are among the scientists who received the Nobel Prize within very short time of 6 years when they started to do the research in the graphene. So in 2000, they got the Nobel Prize for graphene. Graphene is the two-dimensional material. Now, can we see the graphene? Can we make the graphene ourselves without support of anyone? Yes, you can make the graphene. In fact, you are creating the graphene yourself. Okay, so when you rub the pencil, simple pencil, on any papers, what you are doing, you are creating thousands, millions layer of graphene, because graphite is made up of various sheets of carbon atom. Like this is the structure of graphite. So if you look at the structure of graphite, you will find that this sheet, one sheet is attached with another sheet. So these are the carbon atom. 6 carbon atom make one hexagonal ring. Okay, and then similarly one ring is connected to another ring. So that is horizontal sheet, and each sheet is attached to each other, that is graphite. When these sheets are separated by making any kind of force or energy, then this bond between two sheets is broken and you can get a single sheet. That single sheet, single atomic layer of carbon atom is called as a graphene. But if sheets are connected to each other, then it is graphite. So when you rub your pencil, initially it is a graphite, okay? But when you rub, it is this bond which can break and create this sheet. You are creating the graphene, but we cannot see by our eyes because this structure is a nanomaterial. We cannot see by our eyes. If you want to see by your eyes, then you have to use some kind of microscope. So this is a natural example. However, we cannot see by the eyes. And there are other processes through which we can prepare the graphene or several other structures. Those structures are called as two-dimensional material. Now, if we want to prepare two-dimensional material, basically two-dimensional material is a layer material. So this layer material, and why we call it as a two-dimensional. You might heard about three-dimensional. You might heard about two-dimensional. You might heard about one-dimensional. So two-dimensional means it has an X and Y. So it can extend on X direction as well as Y direction. But Z direction is negligible. So this sheet can extend on this direction and this direction also. So it can elongate, it can extend. That's why it is called as a two-dimensional, because this hexagonal ring can be extend on this direction and this direction also. So it can elongate, it can expand on two directions. So that's why it is a two-dimensional material. So to prepare various two-dimensional material, you need one chalcogenide metal atom, and that atom can be combined with another chalcogenide. For example, you can select transition metal chalcogenide from this group, or group 3 chalcogenide from here, or group 4 from this, or even topological insulator like SB or BI. So you select one atom from here and then you mix with chalcogenide like ACS sulfide selenide beryllium. So if you choose MO, okay, or W, MO means molybdenum, or W means tungsten. So MoS2, MoSe2, WS2. These are the various combinations. So if you choose these combination and you select one chalcogenide from this S, Se or Te, you will find possible 88 combination. Out of those 88, 44 are stable combination. Other two-dimensional you can prepare, but those are not stable combination. The widely used two-dimensional materials are molybdenum sulfide and tungsten sulfide after graphene, because graphene was invented in 2004 and it is well recognized in 2010. In last 12 years, beyond the graphene, molybdenum sulfide and tungsten sulfide are the widely studied material or nanostructures. So why the people are creating these two-dimensional structure beyond the graphene? Because graphene is widely used from 2004 till date. There are many research papers. But in case of graphene, this is the hexagonal ring I have shown you. 6 carbon atoms. They are attached to each other. And here only one carbon is required, carbon atom, okay? And it is bind with another carbon atom, creating hexagonal ring. And similarly, it is attached to another ring. And in this way, you can create a sheet. So this is two-dimensional structure. Now, second example is molybdenum sulfide. Now, in case of molybdenum, one molybdenum atom here, which is connected to the 2 sulfur atom. So blue is connected to 2, MoS2. In case of boron nitride, the structures of boron nitride is same as graphene. You can see structure is same. However, the atom are different. In case of graphene, only carbon atom participate, while in case of boron nitride, only boron and nitrogen atom can participate. So what's make the difference? Even though the structure is same. So graphene, molybdenum sulfide or boron nitride, two-dimensional material, we can say yes, they are two-dimensional material. Then what is the difference? If you see the difference, the graphene conduct the electricity, because graphene is having almost 0 band gap. It's act as a metal, while molybdenum is a semiconductor material. Boron nitride is an insulator material. So whenever you are looking for a metal-like property, we prefer graphene. When you are looking for semiconducting properties, then we can prepare molybdenum sulfide. When we are looking for the insulator material, then boron nitride is a good example. So what kind of application we are looking for? According to that, researchers are preparing these materials. So materials, there are many materials, metal-like, semiconductor or insulator. And of course, they have different properties, and those properties can be used for various applications. So in last 12 years, various two-dimensional structures has been prepared. Okay, various method, technique has been used to create these materials. Initially, it was only graphene, then molybdenum, then tungsten sulfide has been prepared. And after that, we can have binary or ternary composite. For example, graphene, molybdenum, and hexagonal boron nitride ternary material can be used for field effect transistor. Beside these regular two-dimensional material, new family like phosphorine and silicene is also prepared. So these are various examples you can find in research paper in last 12 years. Now, I will explain you what is laser ablation process. So you know about the light. We are using laser. Before understanding a laser, you must know what is the difference between a simple light and laser. So when we have a simple bulb, it creates a white light. Okay. Actually, that white light has many colors, many color combination. That white light is widely spread in all directions. So any bulb which shows a white light, basically it has all color in the light. But this all color has a different wavelength. So these wavelength, each different color belong to certain wavelength. And this light is not unidirectional, because light is spreading all over the room. If there is light, it can spread anywhere, in all directions. So this light is not a focus light. It is not unidirectional. That's why we call as a white light. White light has various colors of a certain wavelength. But in case of laser light, if you look at any laser, laser may be red color, green color, blue color. In earlier example, earlier slide, I have shown that white color has many wavelength, and each wavelength shows different color. So it is a combination of different wavelength, and then hold together, it creates a white light. But in case of laser, one single light has a certain wavelength. It is a unidirectional, and that unidirectional light is a laser. So this is light from this laser. If it is a red, then you will find only red color is emitting. Only red color is emitting. If it is a green laser, then such kind of only one wavelength, only one wavelength, one direction. And it is a coherent light also. It is a focus. It is a straight and focus, unidirectional. So we are using laser to prepare nanostructures. So basically what we do to create these nanostructures, we use liquid, any kind of liquid we use, maybe simple liquid like water, or acetone or methanol, or any kind of organic liquid we use. But acetone, methanol, or isopropyl alcohol, or simple water are the widely used material as a liquid material. So in this liquid, we prepare a bulk material. We put the bulk material. So this bulk material is our sample. So bulk material is in the form of powder. Okay, powder. So in liquid, that is, let's say water, we are putting some sample of a powder, and size of these small particle is 1 micrometer or 2 micrometer. Then after putting the powder into the solution, we close this glass with the lid, and then we irradiate these powder using Nd:YAG laser. Now Nd:YAG laser is a nanosecond laser. So this laser has a wavelength of 532 nanometer, and each has 10 nanosecond pulse. Now light is a continuous, but pulse laser means every 10 seconds one pulse is going on. It is not continuous light, it's a pulse, but the duration of each pulse is a 10 nanosecond, and the energy is about 50 millijoule, that is 500 milliwatt. The beam size is 5 millimeter. This beam size is a 5 millimeter. And we can ablate this sample for 20 minutes, for 30 minutes, for 1 hour, depending on the sample. So once we irradiate for, let's say, 20 minutes, this micro particle is converted into the nanostructures. How this happen? It happened because the laser energy, laser has an energy. This laser has a certain energy, and that energy is used to create this nanostructure. How this nanostructure has been created? So laser ablation is nothing but the removal of material from the target material. Now here, this powder is a target material. So when we use laser, basically this high power laser hit the surface of a target. This is target, okay, leading to various physical process. Sometimes it melts, sometimes it evaporates, sometimes it's ionized. So how this process, physical process, occurs at the interface between the liquid and the substrate is happen. So when this nanosecond is ablating the surface of a sample material, the surface of a sample is affected because of the laser energy. It creates heat, it creates a plasma at the surface, and it removes the part from the surface. So basically, because of the energy, that surface is removing some part of the surface of a substrate, and here heat is created because there is a liquid medium. As I told, this is the liquid medium and this is the substrate. So here plasma is created, and due to plasma, the heat region, heat area is created, and this heat affected area remove some part from the surface. However, as we increase the time, this laser goes more deeper inside the target material, and it can create shock wave. Like when you throw any stone in the river, you find that there are circular waves has been created after throwing a stone. Similar thing is happening here. The laser, which is in one direction, when it hits the liquid as well as the substrate material, it is damaging the surface of a substrate or target material, and it is passing through that substrate and creating the shock wave also, shock wave. So this is for nanosecond laser. If we use nanosecond laser, then these nanoparticle can be generated outside the surface of a target material. So here you can see some kind of nanostructure. If we use picosecond or femtosecond laser, the pulse duration and the energy is less. Now picosecond and femtosecond, the pulse duration is very small. The energy is also very small. For example, for nanosecond laser, it is 500 milliwatt. But for picofemtosecond, it is 3 milliwatt or 30 milliwatt. So almost 20 times less or 100 times less than the nanosecond. So it creates very small heat affected area and also the small shock wave. We can create the nanostructures from 5 to 100 nanometer. Now let's look at one of the example of synthesis of indium selenide nanocube. So in this experiment, what we have done, in this research, what we have done? We have used Nd:YAG laser. This is the wavelength, 532 nanometer, and energy was 620 milliwatt. This is the glass beaker. We put indium selenide powder plus water as a liquid, and then it is evaporated for 5 minutes, 10 minutes, 15 minutes, and 20 minutes. So when this target material was ablated for 5 minutes, then we can see how the structure is formed. A rod-like structure after the 5 minutes. But when we increase the time from 5 minutes to 10 minutes, this rod-like structure, it becomes circular. After 15 minutes, it started to get into the shape, but these are irregular shape. After 20 minutes, you will find the formation of nanocube. Now, in this experiment, as we change the time, the nanorod-like structure converted into the small spherical particle as well as small nanorod. So there is a reduction of a particle. I told you, initially, the target material is having a size about 1 micrometer to 2 micrometer. So that 1 micrometer to 2 micrometer become few hundred nanometer. Then 10 minute, it become again small spherical particle. 15 minutes after, there is a size reduction as well as transformation. From circular, it started to take a shape of cubical. But these cubicle are irregular. After 20 minutes, complete transformation into the nanocube. Now, this is the physical process occurs. And after 20 minutes, we can see the nanostructure in the form of nanocube. This is the target material, bulk material. Okay, this is the bulk material. And if you look at the bulk material, its size is more than 1 micrometer. You can say X or Y direction. But at the end of 20 minutes, you can see these nanocube less than 100 nanometer can be seen. So this sheet-like material, this is single sheet. Okay, the top layer is single sheet. There are various sheets of indium selenide, but this sheet material is converted into 3D structures, 3D nanocube. So these are 3-dimensional nanocube structure. And this paper has been published in ACS Applied Nanostructure in 2020. So this was the ACM image of bulk structure, and this is the nanocube. We have seen the XRD, the structure remain intact. We confirm from TM image that structure is still intact. There is no change in the structural phase. So it is still indium selenide. Otherwise, what happened? Sometime indium will be separated and selenium becomes separated, but it doesn't happen. We got indium selenide even after transformation of this bulk material, which is sheet-like structure, into nanocube. And then we have seen the field emission property of this material. Field emission means basically what happened, you apply high electric field to these material and you can able to generate or gain some kind of electric current from it. It is the same principle you are using in your display devices. So we are looking for some material which can use low voltage and create high current density. If we succeed, then that will be the material for new display devices. So here indium selenide can have the current up to 2.7 milliampere per centimeter at 9.7 volt per micrometer. So this much current is created from these nanocube. This nanocube, there are on the wall of each nanocube, there are many electrons that can excite and participate in the generation of this current. So this current is very high as compared to the bulk material. The bulk material, this material showing only current up to 400 microampere. That is not shown here. If we show that, then it is like this, okay? It is like this, almost straight line. Only the nanocube structures field emission curve has been shown. So this high current coming from indium selenide is because of its nanometric structures, and these structure can give high current density because the wall are very thin. When you apply high electric field to these material, the electron can easily emit, and you can see the light emission from the nanocube. So this one of the property of indium selenide which can be used in display devices. Other optoelectronic properties of various two-dimensional material we have prepared. Bismuth selenide is one of the materials. So this is the bulk material. We crush for 2 hours, then make it fine powder, do the laser ablation. This is the before laser ablation. This is the after laser ablation. So you can see that after laser ablation, the solution color is changed. That is the first sign which give an indication that nanostructure is formed. So this was about 120 minutes. This is the before laser ablation. This is after laser ablation. This is the bulk material. Before, you can see the size of the particle because we crush, so it is uneven. And then after 120 minutes, you can see the nanorod kind of structures. And there are two possibilities of the growth mechanism. One possibility is that reduction of the target material or fragmentation. So in case of reduction, when laser is put onto the bulk material totally transform into the small particle, tiny particle, and that tiny particle agglomerate together and make one nanoparticle. So that is creation of nanoparticle. This is one of the mechanism. In fragmentation, the bulk material is break into the several sheet, initially into the few and later on again into the small pieces. So that is fragmentation of nanosheet. Like you break a paper, so you make several pieces. Similar kind of process happen. It depends on what kind of material it used. If the material which is very strong, that cannot break into the small pieces. If material is strong, sheet are generated. Material bond is not strong, then small particle can be easily created. So again, we have seen the field emission property. After 120 minutes, the current density is improved. You can see initially the light emission was very less, but after this structure convert into the nanostructure, the light emission is increases, as we can see in this photos, or this current density is increases from 400 to 674 microampere per centimeter. Beside indium selenide, bismuth selenide, we have prepared molybdenum sulfide also for 120 minutes. Then you can see the structure. This is the bulk structure. These are the small structure. And then again, it turns into the good sample for field emissions. So basically, when the ablation time is changes, the structure is also changed. And as we increase the time, we can get smaller nanostructures. So here another example is tungsten sulfide. This time we use nanosecond and femtosecond laser. Okay, here in case of nanosecond laser, the particle up to 20 to 200 nanometer are created, but those particles are attached to each other. When we create the particle, most of the particle are attached to each other. In case of femtosecond laser, most of the particle are well separated from each other, well separated. Here it is a dark, maybe picture you can see, this means that there are many particles. Here the picture is gray, that most of the particle are well separated. And in ACM or TM image, you can easily confirm. Then we have also seen the FET behavior of bismuth selenide material. Bismuth selenide is a topological insulator material. When we talk about the bismuth selenide material, the bulk bismuth selenide is a topological insulator, but when it convert into the nanoscale material, nanostructure, it acts as a semiconductor material. Now, this material can be used as a field effect transistor material, and it can show the flow of current. Here, the charge conduction is mainly due to the N-type carrier, and this paper is also published in 2019. We are doing ongoing research on various material, molybdenum, indium selenide, tungstens, or bismuth sulfide also, using femtosecond laser, nanosecond, and bismuth selenide is the widely studied material in our laboratory. We have prepared various form of bismuth selenide material, nanoparticle, nanosheet, nanorod, nanocube, nanotubes. However, we have to still study more detail about these material, how these material are formed and what is the growth mechanism. So we are studying these material in detail. In future, we want to develop two-dimensional material which can be used to exploit the new property that can be used for the optoelectronic devices. So in future, we want to create new type of two-dimensional material which is made up of maybe traditional chalcogenide material, but exhibit a different kind of property that can be used in the field of optoelectronics. So that is our ultimate aim for future study. Of course, we are using LAL, means laser based ablation. And I would like to thank our collaborator in Tokushima, Professor Furbe, collaborator in Pune, Professor More, and these are my graduate student and doctoral student. Thank you very much. These are the activity Tokushima University sometime organized for the student. Thank you very much for your patience. If you have any question, I'm ready to answer your question. Thank you very much. Hello. You are, please unmute yourself, sir.
What?
Yeah. Okay. I got one. I got one of the question. Okay. This question is from Ansari. Okay. He is asking the question how he can create the graphene using Scotch method. Scotch method, you can create the graphene. However, it is not uniform. You will not get the single layer, because what happens when you put the tape, you are not putting the uniform force. So when you attach the sellotape to the surface of a target material. And when you remove, while removing, there are many layers can come together with that tape. So it's very complicated method. Sometimes you can get a single layer, but sometimes you can get multi-layer. Since the applied force is not uniform, we are not sure you will get the graphene or not. It is similar, like I show you one of the slide, very first slide, that you are rubbing the pencil. When you rub, it is depend on how much force you are applying. If you are generally rubbing, then small graphene will create it. But if you put additional force, then big layer will be formed. Similarly, with the Scotch method, there is a limitation that when you apply the force, it should be uniform. When you remove the tape, it should be uniform. Then and then you will able to create. Gently you should try, just attach and very gently remove. Do not use too much force. Then maybe you can get some good result. Is this correct answer, Ansari, or do you have another question?
Yes, sir. Sorry, sir. I also want to ask one question to you.
Yes.
Sir, you have shown us that we can use water for the synthesis of nanocubes of indium selenide. So if we change the solvent, then can it affect the electrical or physical properties of the indium selenide?
This is very good question. Excellent question. Actually, I told you that we can use several organic liquid, for example, water, ethanol, methanol. Now, in our case, when we started the experiment of this indium selenide, we started with the isopropyl alcohol. And in case of isopropyl alcohol, we just got the particle like this, okay? Just the nanostructures, nothing more than that. But we are not looking for the spherical nanostructure because there are lots of paper on the spherical nanostructure. And nanostructure, which having the spherical shape, is not the innovative material. But we were looking for something different. So we changed the solvent from water to ethanol, ethanol to methanol. And then finally, we tried for water. When we tried for water, the result was like formation of nanocube. Of course, the organic liquid is the important parameter which can change the structure. Now, if the structure is three-dimensional structure or single layer structure, it can show excellent electric properties. But if the structure is bigger, then it can show a different property. It affects the property structural as well as electrical or optical also. So small particle, if they are well separated, it can be act as a insulator. If the particle are well connected, it can be act as a semiconductor or conductor type. So both way, structural as well as physical property can be changed depending on the solvent.
Thank you very much, sir. And again, I offer my sincere thanks to you, sir. And also I offer my special thanks to Professor Abule, sir. Because of him, you are available to us and you give us a very informative lecture. Thank you, sir.
Okay, thank you very much.
Sir,
Thank you.
Abule sir wants to talk with you, sir.
Okay.
हेलो
Yes.
आप उनका पहचाने कि नहीं?
Yeah, fish. Okay. Yes. You change a lot.
पहले दाढ़ी नहीं थी, अभी दाढ़ी आ गई है।
Yes. You
उनका
change a
आप
lot.
बहुत स्मार्ट बन गए, यानी आप भी थे तो ऐसे नहीं थे, अभी तो स्मार्ट दिखने लगे हो। ये जापान की हवा का असर तो नहीं है?
नहीं, I don't know, but it may be.
वहाँ पे जो है ओल्ड एज देखो तो 100 के ऊपर जाते हैं, हम लोग इंडियन तो 80 70 80 में लोग जाते हैं। आपके बाल भी रुक गए, वहाँ पे था जितना पुणे में था उतना अभी भी दिख रहा है मुझे। Okay, sir, I have one question.
Yeah.
Here we are talking about laser light And if we are talking about laser line, then it is a stimulated emission of radiation.
Mhm.
Now, in
Yes.
field emission, we are talking about particle emitted sunlight.
Yes.
But we are going to incident laser light on it. Okay. So light is spontaneous emission and laser light is stimulated emission.
Yes.
So what is the relation while we are going to collide these two light in case of field emission?
Actually, laser, when we create the nanostructure, we use stimulated light, because if we use the spontaneous light, then the structure formation will not be uniform. Okay, so stimulated emission can have a unidirection and it can hit the target material in one direction and create the uniform structure. So that's why we are using laser for that. That is one thing. A field emission is a different concept. Field emission is a material property, and after creating the nanostructure, we employ high electric field to a nanostructure. When we apply high electric field, the nanostructures which receive the electric field that can excite the electron and emit the electron. That is, optically you can see the electron is emitting from the surface. So this principle is almost same like our any display devices. So synthesis is a different process and material property is a different. In case of synthesis, we are using spontaneous emission of laser, and in case of property, we are using the electric field to excite the electron. And when electron is exciting, it bombard on any screen, and when electron is excited and it hit the screen, that emission of electron can be visible, like I have shown on the field emission curve. Small
So while
particle.
we are talking about field emission curve, we are talking about different shape of particles. Particle is either a spherical shape or tube shape and another shape.
Yes.
And you said that I observe maximum emission from the cubical shape.
Yeah. Yes.
So what is
Yes.
the effect of tube on that field emission?
Field emission, like if you use the low voltage and you can create high current, that is a good cathode material. Cathode material means which can generate high current, because high current means electron movement is more and it can create the emission in the form of light. So that can be used for creating the image. Okay, so field emission, we are using the high electric field. Now, if the material is, let's say, spherical, okay, so if it is a solid spherical material and you apply high electric field, what will happen? The top surface of that nanostructure, very few electron will participate, very few electron will emit, because less surface. And in case of cube, let's say, and that cube is a wall, is a thin wall. Nanocube 3-dimensional structure is a thin wall. Once you apply electric field to that thin layer, most of the electron from the surface will participate. Most of the electron from all over the part. In case of spherical, only the front surface will participate. But in case of spherical, large surface area will participate in electron emission. That's why we are getting more density, current density from the.
Last question.
Yes.
You are using ND-arc laser. ND-arc laser. Can we use ruby laser or semiconductor laser? Especially you use ND-arc laser.
I think ruby may be difficult. I think micro, nano, femto, picosecond is okay. Ruby laser might not, might not have that.
Or anything other.
No, basically there are two parameters. One is wavelength and another is the power. Okay, if the power is very high, the material will simply melt. Okay, that will be the most like ionization or vaporization or melting process will take. But in case of micro, nano, pico or femto, the pulse duration is very small. It hit the surface. It hit the surface in that micro, pico or nanosecond. So that's why less damage. And continuous laser you cannot use. Okay, continuous laser if you use, it will break the all bulk material instantaneously, and you will find that will melt. So ruby or continuous laser is not good for these.
Thank you, sir.
Okay.
तो प्रशांत सर, क्विंकर सर,
Yes.
एक रिक्वेस्ट है आपके पास, जब भी पोजीशन होगी हम लोगों को बताओ। हम लोग हमारे यहाँ पे केमिस्ट्री डिपार्टमेंट है, हम लोग
Yes.
अपने स्टूडेंट को जापान पीएचडी के लिए दे देंगे, लेकिन पोजीशन रहेगी तो डेफिनेटली हम लोगों को बताओ।
पोजीशन
अगले साल नहीं, उसके बाद
नहीं, अभी पीएचडी की
पोजीशन ओपन होती है बताओ, क्योंकि हम लोगों के कॉलेज में काफी अच्छे ब्रिलियंट स्टूडेंट होते हैं और हम लोग चाहते हैं कि हमारे स्टूडेंट बाहर जाए और कुछ अच्छा काम करे। तो आप जैसे लोग अगर कोऑपरेट करेंगे तो हम लोगों को बहुत आसानी होगी अपने स्टूडेंट बाहर भेजने के लिए।
एक्चुअली अभी नेक्स्ट वीक 3 इंडियन स्टूडेंट आ रहे हैं पीएचडी के लिए, बट मेरे पास स्कॉलरशिप अभी नहीं है। दे आर कमिंग ऑन देयर ओन।
जब भी आपके पास स्कॉलरशिप रहेगी बताओ, जो भी एग्जाम वगैरह टेस्ट वगैरह रहेगा हम लोग क्लियर करवाएंगे, यहाँ पे स्पेशली प्रिपेयर करवाएंगे बच्चों को, ताकि हम लोग बोल सके कि हमारी कॉलेज की एक लड़की गई, गर्ल्स कॉलेज है, हम लोगों की गर्ल्स कॉलेज है, तो हम लोग बोलेंगे कि हमारे गर्ल्स कॉलेज की लड़की जाके जापान से पीएचडी करके आई है।
No, that will be absolutely no problem. I will contact you. But कैसा, अगर स्कॉलरशिप रही तो I will definitely contact you.
फाइनेंशियली हम लोग इतने स्ट्रांग तो नहीं है कि सिर्फ जाके कर सके।
Yeah, that okay. If there is any such opportunity, I will definitely contact you. Okay, no problem.
Thank you for your cooperation, sir. आपने 11th hours में हम लोगों की बहुत हेल्प करी, लेक्चर डिलीवर किया और आपका स्टार्टिंग पॉइंट मुझे बहुत अच्छा लगा, बहुत मोटिवेशनल था। आप बताए आप इतने साल यहाँ पढ़ते, इतने साल यहाँ पढ़ते, ऐसा अगर आप बताते हो तो स्टूडेंट के अंदर एक थोड़ा सा वो होता है, मोटिवेशन पैदा होता है कि हम लोग भी कर सकते हैं, अगर पंकज सर कर सकते हैं।
ये एक्चुअली मेरे पास टाइम कम था, इसलिए मैंने वो स्किप किया मोस्ट ऑफ द पार्ट, अदरवाइज आई कैन।
अभी नेक्स्ट सेमेस्टर में एक और कॉन्फ्रेंस रखेंगे फिजिक्स और केमिस्ट्री मिला के, उसमें हम लोग इंटरनेशनल कई स्पीकर्स को बोलेंगे, उसमें से एक आप भी रहोगे और दो मेरे दोस्त हैं, एक अपना जो था ना क्या नाम है, रवि, यूएस में रवि डे ब्रुकलिन, और विश्वास था वो भी
पता है
बर्कली यूनिवर्सिटी में यूएस में, इन दोनों को भी हम लोग इनवाइट करेंगे। तो नेक्स्ट सेमेस्टर में प्रोबेबली वी विल अरेंज वन कॉन्फ्रेंस तो यानी सम पब्लिकेशन प्रोसीडिंग वगैरह के साथ, तो उसमें भी आपका कोऑपरेशन चाहिए हमको।
Okay, no problem. Thank you.
Sir,
thank you very much. Bye. Thank you.
Thank you, Abhinav sir. Thanks all the participants who joined with us and make this program a successful program. Thanks a lot. Thank you. The link for the feedback is given in the chat box, so you can fill up the feedback form as per the link. Okay, thank you.